I just went and recorded an almost half-hour video and realized that I waited until the end of that half hour to actually show any results. So here are the results up front. Just as a comparison, we can see the, whoops, go down. We can see the original ray tracer is here. And then here is my implementation of the same thing. So I may have implemented the maze generation algorithm slightly, what's the word, incorrectly. Otherwise, we've got pretty much the same stuff. So we've still got reflectance, we've still got shadows, and hopefully, to me, as far as I could tell, there was also sort of a warping effect on the original, which doesn't seem so bad in my version. Like if we were to compare, this is my version again, and then this is the original version. There, I'm not sure if you can see, but on the ceiling, there seems to be this, and on the walls here, there seems to be a sort of fisheye effect. I don't know. Okay, so those are the results. Let's get into the code review. Hello, how's it going? I hope you're well. Recently, I've been reviewing a lot of people's codes for my work, and I thought I'd have some fun. I've got a week off now, and review some other sort of graphics programming or YouTubers' code. Why not? Just settle in, have a coffee, and let's get into it. So I just want to let you guys know this is not me making beef, okay? Everybody has to start somewhere. And my own code, when I first started programming, was not good at all. I'm only going to be reviewing code of people whose work I admire, and the following code, the code that I'm going to be reviewing today, is by a YouTuber named FinFet Productions. We were sort of coming up around the same time. While FinFet's work is brilliant, it has some areas that could do with a little more explanation, and I had the time, so I thought, let's dig into it. So to start with, what is the program? Well, pretty much this is a ray tracer, but as you can see, it's a ray tracer written in matplotlib, so we can use sort of keyboard input to move around. Got a light there. Whoops, where are we? Somewhere here we should have some reflective materials. Like this is a reflective material, for instance. I didn't even see that. I thought that was a doorway. Yeah. We've got reflective materials, we've got shadows, we've also got sort of like approximate soft shadows happening. So there's a lot to like here. This is very, very and it's visually beautiful. Like there's a good use of colors, and we can also use the mouse to look around. So if I look up a little bit, whoops, we can start to look up and down and left and right. Oops, and like it's very cool. So again, before I really dig into this code review, positive points are good use of color, very creative, good effects, they seem accurate enough, shadows, reflections, and all of that. And like I said, this is fully ray traced, so it's very good. And of course, getting the stuff done in matplotlib is commendable. Okay, what I'll do is I'll look through this code, I'll try to pick it apart, and then in a second when I'm done, I'll show my implementation or re-implementation. So to start with, here's our main program. We have this global variable named key, and I know that global variables are sort of a cardinal sin, I guess, but because when we go ahead and set up the listener with the pi input keyboard module, that is done, well, the listening is done via a callback. This onPress callback function, which is defined down below, only takes in one argument. So the only way, I guess, to really modify something like a variable here would be to use it as a global variable. Now, it's not quite the only way. If we had object orientation, what we could do is we could say something like could make a function which takes in something like that. So if we had some sort of instance of an input system, this is just pseudocode. If we had some instance of an input system, then we could call its onPress function. Now this lambda, what that's doing is it's defining this as a function. So it takes key as its input and it will call that onPress function with the key. Having this instance of an input system gives us all of the context that we need. It wraps that context up so that the usage of the key variable is not a global variable. It's just a variable within that input system. Now, short of using object-oriented programming, a global variable in this case is a reasonable approach for a demo program. Okay, so then we have the size of the map. Then we go ahead and initialize the player's position. Now this is slightly ambiguous, I guess, because it says pos. Okay, so if I see X, Y, Z, I can pretty much guess that's a position, but it's like position of what? And likewise here with rot, I guess rot for rotation, but then we have rotation and vertical rotation. But again, so what does that mean? Now here on the line below, we are running an algorithm to generate the maze, and I'm starting to see a problem. This map C, map H, and map R, again, this is not the most descriptive variable name. I would probably go with something like block colors, for instance, because what this is generating. Right, okay, quick question. Look at this line and try to imagine what these variables actually mean. Right? So C is for block colors, H is actually for the heights of the blocks, and R is for the reflectance values of the blocks. We can see that down below in maze generator. Well, sort of, right? I mean, we can, if we're lucky, we can guess that that's what it means. We would actually have to read through the whole program to know what these things actually are. Sort of my first impression from this is that these variables need meaningful names. So again, I would rename these. I would actually also bundle them all together, probably, because most of the time I'm dealing with the map, I'm actually passing over most of that information. So if I were to look down here, where this reflection ray is being cast, I need to know about the colors of the things on the map, and I also need to know about the reflectance values of the blocks on the map. Likewise, if I look at view ray, well, I guess here, yeah, we need to know the map colors and the map heights. But one thing I'm seeing about these function calls is that they have a lot of arguments, which are probably unnecessary. And so I would try to actually bundle this block colors, block heights, and block reflectances into a single tuple of NumPy arrays and pass that around and unpack it as I need it. Likewise with this exit y and exit x and exit y, there's no reason for those to be two individual variables. They don't change. And also, even if they did change, it's extra typing, like it's big. So again, I would bundle those into a single tuple, call it like exit position, and then see anytime I'm passing in exit x, I'm also passing in exit y, so I'd probably pass that in as a tuple. Now here, mod. Mod, again, is not the most meaningful variable name. Actually, I don't know what it means. What does it mean? And similarly with ink, see, although these variable names are sort of commented, if you need a comment and the comment says the same thing as, like, this resolution modifier could be a variable name, and it doesn't cost anything to just set that as the variable name instead of making a comment, because then anytime I see mod, I have to look up and see, okay, what was that? And it's just an extra load on the reader, which is not necessary. But we haven't even gotten to the worst offender in terms of variable names, not by a long shot. The worst offender here would have to be dtol. Dtol. What does dtol mean? I pulled up Google. I searched the literature. I searched ray tracing, dtol. Is that like depth tolerance? Is that distance tolerance? It turns out dtol means distance to light. Why not name the variable distance to light? I don't know. I mean, that's just, I don't want this to come across as overly sassy. I've done this before. I just think there's a better way. I think this could be a lot clearer. So in terms of how I approach this, the first thing I did is I renamed the variables. I gave them all meaningful names. C, that's color, so just call it color. Okay. Here this pos x, pos y, pos z, that's really, it's all related info, so I just bunched it together as one tuple, reduce the number of arguments. Similarly here, this is, I don't know what this is meant to mean, but it's actually the raise step, the components of the raise direction. So I bundled those together as one thing. Light position, I bundled that together as one thing. You can see where I'm going with this. Then, in some cases, where possible, I made helper functions to make this a little bit clearer. So like, although this is pretty clear, I just made a helper function for it. Why not? And there was a few more things I wanted to mention. Okay, so if we go down to this viewRay function and we look at dtol, okay, distance to light, h. Quick question. What do you think h means? If you guessed intensity, then you're correct. H is measuring the intensity of the light energy received at a point. I've got a light over here. Here I have some certain value of h, like 0.75. Here, as I get closer, I decrease my distance to h, and so my intensity, light energy at that point, increases. 0.9, 0.1. Here, 0.25 or something. So h stands for intensity. That definitely makes sense, since intensity, that's actually how it's pronounced, by the way, it's intensity. I should dial the snark back a little bit. It's just that whenever I see poor variable names, I ask why. Why? I don't get it. Why? But anyway, and then the other piece of feedback I would have is, if I write the code and then I forget what it means, there are a few things we can do. First of all, we can give the parameters type hints to indicate like what data type is expected. And secondly, we can write docstrings. You're allowed to write docstrings. Okay, so dial it back, get rid of the snark. I'm sorry about that. I didn't mean to chew it out too much. But really, I evaluate students' code for a living professionally, and if a student answered an assignment with code like this, I would fail them. Point blank. So here is my revised version. To start up, we declare, any global variables that we need, give them initial values, and then I've got this first stage where we set up the input systems. So that occurs down below. So note that I am noting the expected return type of the function. I've got a short description of the function. This makes it much easier to understand the code. Pretty much set things up the same way as before, but just pass that back. So it's about the inputs and outputs of the functions. Okay. Also note that I've got regions. You can do this. Go, hash region, and that gives you a collapsible region of code. It makes things easier to organize. Similarly, we can make a player. This takes in as its input the size of the map, and it returns the position and rotation. Just like that. See, everything is clearly noted. But my point is this is much more, it's cleaner, it's more readable. And I know some people say, hey, clean code, bad performance. Well, guess what? I don't want to work with bad code. Because it's one thing to say clean code, bad performance. It's another thing to call your light intensity H and your distance to light dtol. Okay, just putting it out there, just saying. Go ahead, we build the maze, and then we set the detail level. That's right, mod is the detail level, and set up, calculate our screen resolution and our ray length, set up the screen, basically, allocate the color buffer. One thing that didn't quite make sense, if I just go back to the original, is that in the main loop, every single frame we were starting off with a set of empty pixels, and then we were appending into that. That's not so good, because we know that the number of pixels on the color buffer is never going to change. I don't see why we need to continually clean it off and then append to it every time. So in my version, what we're doing instead is we pre-allocate all of the color buffer. We go through, we do our stuff. Once we've finally calculated the color, we just pack it into the color buffer in the appropriate position. So we're not reallocating memory. We're always just working with fixed size memory that doesn't change. So I did change the view method as well. Instead of going with a more ad hoc method, what I did is I calculated via linear algebra the camera's forwards, right, and up vectors, so we can see here, and then we can sort of blend, take some coefficients, and then the direction that a ray is going to go through a pixel is some linear combination of its forwards, right, and up vectors, depending really on which pixel of the screen it's going through. I just go ahead and normalize it and set it to the appropriate ray length, and then trace. Otherwise, it's pretty much the same. So hopefully, as you can see here, a lot of this stuff has been bundled together. So X, Y, Z was bundled together as ray position. Same thing with ray direction. Same thing with map data, light position, exit position. It's all bundled together. So the way this works is, first up, we shoot a primary ray. And that primary ray, here we have it, that primary ray continually steps forward until it hits a block. So we can actually have a look at that. What this is doing is, if we open up the shoot function, we just read off the ray position, ray direction, and then we continually step forward in the ray direction until either we hit the ceiling or floor, so our Z exceeds the appropriate bounds, or we hit a block which is taller than our ray at that position. In other words, the block is here, the ray hits it here, we are done. Okay, and then in the end, we simply return the position that we hit. Yeah, it's bigger, for sure. It's a lot more lines of code, so you have to explicitly mark everything off, but it is easier to understand, I hope. And yeah, let's talk about shadow rays as well. So the ray has gone ahead, it's shot out into the world, we've shot our primary ray, we've sampled our position somewhere, and then there's a light. What we're going to do is continually step in the direction of that light, and then every time we are in the middle of a block, the light energy is decreased by a little bit. And this does a pretty good job of approximating soft shadows, because a light ray which has an uninterrupted path to the light will just get full energy, and then a light ray which has to travel through a lot of blocks will have reduced energy. But as you can see, pretty much, we explain this here. So I've just got a multi-line comment that I've inserted, just pretty much explaining all the steps. And so I understand that this is dragging on a lot, so I'll sort of curtail it at this point. I just want to run this and show it. Okay, so here's my version. I did slightly different post-processing. My gamma correction is a little bit different, but there we go. We have the same effects. We got shadows. We've got reflectance and everything. But the code is, I would say, better designed. I don't know. What do you think? Okay, so there we go. That was the code review. Now I realize that FinFET has other bits of code which are, longer, and I just wanted to pick one that I could quickly sort of rewrite over the course of a few days. Like, are there any other YouTubers whose code you would like me to review? Happy to do it, provided I can write it all, rewrite it in the matter of a few days. Let me know down below. Anyway, that will be it for me. I have an immense volume of marking to do, of work to do, but I'll get back to it. All right, have a good one. Bye.